Welcome to Team Paya-Math, kung saan tuturuan ko kayo pagyamanin pa ang iyong mga nalalaman tungkol sa math. For our topic for today, let's have this video!
So for our topic for today, I'm going to discuss about geometric sequence. This is the topic intended for the week 3 of grade 10 mathematics. So before I discuss about geometric sequence, let's have first our learning objectives. These are the most essential learning competencies that we need to achieve after this discussion. First, we're going to illustrate geometric sequence. Second, differentiates geometric sequence from arithmetic sequence. The third one, finds the nth term of a geometric sequence. So, what is the definition of a geometric sequence? So if an arithmetic sequence or if arithmetic sequences are formed by addition, geometric sequences are formed by multiplication. Geometric sequence, it is a sequence in which each term after the first can be obtained by multiplying the preceding term or the previous term by a fixed constant. The fixed constant is called the common ratio, which is denoted by R. So let's have an example. So let's consider the sequence 1, 2, 4, 8, and 16. So as you can see here, to find for the next term, in order for us to get 2, we multiplied 2 to the previous term, which is 1. And then in order for us to get 4, we multiplied 2 to the previous term, which is 2. Same as to get 8, we multiplied 2 to the previous term, which is 4. And so on. Okay? So, meaning, since we multiply a fixed constant, which is 2, to get the next term, that means the common ratio now is 2. Okay? The other way to find for the common ratio is by dividing the previous term to the next term. Okay? So, we divide 2 by 1. 2 is the second term. And then, divide by 1. We will get 2. So, we also divide 4 by 2. We will get 2. Okay? So, in this case, this shows that the common ratio is equal to 2. Now, let's have another example. So, in this example, let's determine whether the sequence is an arithmetic sequence or a geometric sequence. So, let's have the first one. In letter A, we are given 8, 10, 12, 14, and then 16. Okay? So, let's check first whether this sequence has a common difference or has a common ratio. So, first, let's determine whether this has a common difference. So, I'll take any two consecutive terms and then we subtract them. So, in this case, I will consider 10 and 8. I will subtract them. This will give me 2. I will take another two consecutive terms, and those are 12 and 10. This also gives me 2. Okay? So, let's have another one. So, 14 minus 12 will give us 2. Since there is a fixed or there is a common difference, therefore, this given sequence is an example of an arithmetic sequence. Okay? Let's have the second one. For the second one, we are given 8, 4, 2, 1, 1/2, and so on. Now, we first determine whether this has a common difference. Again, we take two consecutive terms and then we subtract them. So in this case, I will take 4, subtract 8 from it. I will have negative 4. I will take another two consecutive terms. Those are 2 and 4. I will subtract them. If you subtract 2 and 4, it will give us negative 2. And based on the previous difference that we have, which is negative 4, this is not equal to negative 2. They are not equal. Since these two are not equal, therefore, this cannot be an arithmetic sequence. Okay, so let's try whether this has a common ratio. Again, how are we going to find for the common ratio? We divide the two consecutive terms. Okay, so let's consider 4 and then 8. I will divide 4 by 8. This will give me 1 half. I will consider another consecutive terms. I have 2 and 4. If I'm going to divide them, this will also give me 1 half. Okay, let's have another one. So I'm going to consider the fourth term and then the third term. This is equal to 1 half. Since we have a fixed ratio, which is 1 half, therefore, the given sequence that we have is an example of a geometric sequence. So let's have another example. We consider example number 2. So in example number 2, we must find the common ratio and the next three terms of each geometric sequence. So let's consider letter A. In letter A, we are given the geometric sequence 6, 12, 24, 48, okay, and so on. Okay, so the first thing that we need to do is we need to find for the common ratio of this geometric sequence. And how are we going to do that? Again, we divide the two consecutive terms of this geometric sequence. We can consider the first two terms of this sequence, which are 12 and 6. So I'm going to divide 12 by 6. This will give me 2. Same thing, if I'm going to consider the second term and the third term, if I'm going to divide the third term by the second term, this is equal to 2. And same thing, if I'm going to divide 48 by 24, this will also give me 2. Since they have a common ratio, which is equal to 2, then we can say that our common ratio is equal to 2. So we already answered the first question in the instruction. So what we're going to do is to determine the next three terms of each sequence. Okay? So take note that in a geometric sequence, in order for us to get the next term, we multiply the common ratio to the previous term. And we stop with 48 as our fourth term in this sequence. So continuing this, to get the fifth term of this sequence, a sub 5 is equal to 48 multiplied by 2, which is equal to 96. Then we have a sub 6, which is equal to the previous term, which is a sub 5 times 2. And a sub 5 is equal to 96. So this is 96 times 2, which is equal to 192. And then the last one, the last term, a sub 7 is equal to a sub 6 times 2 times the common ratio, which is equal to 192 times 2, which is equal to 384. So these are the next three terms of this sequence. We have 96, 192, and 384. So now let's consider the second example. In the second example, we are given with the sequence 1 over 2,500 followed by negative 1 over 500. Next, we have 1 over 100. The fourth term, which is negative 1 over 20. Again, we must look for the common ratio of this geometric sequence. Again, to find for the common ratio of a geometric sequence, we divide or we get the ratio of the two consecutive terms. That is, I'm going to divide negative 1 over 500 and 1 over 2,500. Since we have here a fraction divided by another fraction, as we all know, in simplifying this, we will have negative 1 over 500 multiplied to the reciprocal of the fraction in our denominator. So to get the reciprocal of this, we will have 2,500 over 1, and then we proceed to multiplication. We can cancel 500 and 2,500. This will give us 1. This will give us 5. Then we proceed to multiplication. Negative 1 times 5 is negative 5. 1 times 1 is equal to 1. So this is negative 5 over 1, or just simply negative 5. Now, we look for another consecutive terms to verify whether negative 5 is really the common ratio of this geometric sequence. So I will consider 1 over 100, then divide this by negative 1 over 500. This is equal to 1 over 100 multiplied to negative 500 times 1. Simplifying this, we can cancel 100 and negative 500. This will give us negative 5. 1 times negative 5 is equal to negative 5. So this is just equal to 1. So 1 times 1 is 1. So this is equal to negative 5. Since the ratio of these two terms here is negative 5, which is the same as the ratio of our two previous consecutive terms, then therefore, our common ratio is equal to negative 5. We're going to use this to determine the next three terms of this sequence. Since in the geometric sequence that we have, we stop with our fourth term, then I will compute for the next term, which is a sub 5. A sub 5 is a sub 4 times the common ratio. So a sub 4 is negative 1 over 20. Multiply this to our common ratio, which is negative 5. This one. If you're going to multiply negative 1 over 20 by negative 5, we will get positive 1/4. Okay? So, meaning the next term after negative 1 over 20 is 1/4. Next, we solve for a sub 6. A sub 6 is equal to a sub 5 multiplied by the common ratio. So, a sub 5, which is 1/4, multiply this by negative 5. This is equal to negative 5 over 4. Next, the last term is a sub 7, which is equal to a sub 6 multiplied by r. A sub 6 is equal to negative 5 over 4. We multiply this by negative 5. Then, this is equal to positive 25 over 4. So, the next three terms of this sequence are 1/4, negative 5 over 4, and 25 over 4. So now, let's consider an example in order for us to know on how to use the formula for the nth term of a geometric sequence. Let's consider example number 3. In example number 3, find the 11th term of a geometric sequence, negative 40, 20, negative 10, 5, and so on. We need to get all the given that we're going to use. So, from the sequence, we are given a sub 1, which is equal to negative 40. And then, we are given the common ratio. But we still need to find for the common ratio. So, R is equal to the ratio of 20 and negative 40, which is equal to negative 1/2. This is also the same as the ratio of negative 10 over 20, which is, of course, negative 1/2. Then, we're also given with the value of n. N is equal to 11. Since we're being asked to find for the 11th term, or a sub 11. Now, to find for the value of a sub 11, of course, we're going to use the formula a sub n equals a sub 1 times r raised to n minus 1. Replacing all the values of the variable in the formula, we're going to have a sub 11 equals a sub 1 times r raised to 11 minus 1. But we have a value for a sub 1, so we replace a sub 1 by negative 40. We also have a value for r, and that is negative 1 half. We raise this to 11 minus 1, which is 10. So a sub 11 is equal to negative 40 multiplied to negative 1 half raised to 10. This is equal to 1 over 2 raised to 10. So a sub 11 now is equal to negative 40 multiplied to 1 over 2 raised to 10 is equal to 1 over 1024. Now, multiplying negative 40 and 1024, we will have negative 40 over 1024. Simplifying the fraction by by dividing their GCF, which is positive 8, we will have negative 5 over 128. And this is now the 11th term of the geometric sequence. Now, let's consider another example. So let's have example number 4. Find the first 4 terms of the geometric sequence with the first term, or a sub 1, which is equal to 2, and a sub 3, which is equal to 8. Now, take note, we are given with a sub 1, which is equal to 2, and a sub 3, which is equal to 8. In order for us to get the 4 terms of this geometric sequence, we must know the common ratio of the geometric sequence. So how are we going to find for the common ratio of this geometric sequence? We're going to use the formula a sub n equals a sub 1 times r raised to n minus 1 in order for us to get the value of r, or the common ratio. Since we are given with a sub 1 and a sub 3, then in the formula, we're going to have a sub 3 is equal to a sub 1 times r raised to 3 minus 1. Since we have a value for a sub 3, which is equal to 8, I will then replace a sub 3 by 8. Then we also have a value for a sub 1, that is 2, multiplied to r raised to 3 minus 1, or raised to 2. Simplifying this equation by solving for the value of r, so divide both sides by 2. So cancel 2. R squared is equal to 4. Extracting the square root of both sides, so we have the square root of r squared is equal to the square root of 4. This is equal to, r is equal to plus minus 2. So we have two values for the common ratio. Now, if we consider r to be positive 2, then we will have the terms starting with the first term, which is equal to 2, multiplied 2, the common ratio. We'll have 4 multiplied 2 again. We will have 8, which is the third term. And then multiplying by 2 to 8, we'll have 16. This would be the first 4 terms if the common ratio is equal to 2. If r is equal to negative 2, we will start again with 2. Multiplied by negative 2, we will have negative 4. Then, multiplied again by negative 2, we will have positive 8, which is the third term. And then 8 times negative 2 will give us negative 16. So, if we consider the negative 2 as our common ratio for this geometric sequence, we will have this sequence. So, we have two answers for this question. Those are the sequence 2, 4, 8, 16, and 2, negative 4, 8, negative 16. But what if we are given a term and we're being asked to find for the position of that number in that sequence, just like this one? In the geometric sequence, 24, negative 18, 27 over 2, and so on, which term is 2,187 over 512? So to solve for this one, again, we're going to use the formula a sub n equals a sub 1 times r raised to n minus 1. Take note that in the problem, we are given with a sub 1, which is equal to 24. We are given with the last term, which is 2,187 over 512. And, of course, we can solve for the common ratio. The common ratio is equal to negative 18 over 24. This is equal to negative 3 over 4. We're going to use this given and this formula in order to solve for n. So in the formula, we're going to replace all the variables with the given value. So we'll have a sub n is 2,187 over 512. A sub 1 is equal to 24. R is equal to negative 3/4. Then we retain n minus 1 since we're looking for the value of n. Simplifying both sides. So I'll first divide both sides by 24. Divide this by 24 so that I can cancel 24 and 24. Now, to simplify the left side of the equation, take note that this is a fraction divided by 24. Again, to simplify this one, we're going to have 2,187 over 512 multiplied to the reciprocal of 24, which is 1 over 24. This is equal to the quantity 3/4 raised to n minus 1. Now, but what is the simplified form of the left side of our equation? Take note that 24 and 2,187 has a common factor, and their common factor is 3. So, if we divide 24 by 3, this will just give us 8. 2,187 divided by 3 will give us 729. So meaning on the left side, we will just have 729 over 512 multiplied to 8. This is equal to quantity 3/4 raised to n minus 1. Simplifying the left side now of the equation, this is equal to 729 over 4,096. This is equal to negative 3/4 raised to n minus 1. Now, 729 can be expressed as a power of 3. And that is 729 is 3 raised to 6. Same thing with 4,096. 4,096 can be expressed as a powers of 4. So, 4,096 is equivalent to 4 raised to 6. And take note that this is equal to negative 3/4 raised to n minus 1. Now, we can simplify this using the property of the exponents. So, this is just equal to 3/4 quantity raised to 6. And this is equal to negative 3/4 raised to n minus 1. Solving now for the value of n in this equation, in order for us to equate each exponents, 6 and n minus 1, they should have the same base. Now, but here, we have the base which is positive 3/4. Here, we have negative 3/4. So what are we going to do is, instead of considering 3/4 here, I will consider negative 3/4 as my base. And then, as we all know, if we raise it to the even power, which is 6, then the negative here will just be equal to the positive 1. Okay? So, meaning negative 3/4 raised to 6 is just equivalent to 3/4 raised to 6. Now, so that we will have equal bases to the right side, which is negative 3/4 raised to n minus 1. Now, since they already have the same base, then we can equate each exponent, which are 6 and n minus 1, solving for the value of n is equal to 7, meaning the given term, which is 2,187 over 512, is actually the 7th term. So 2,187 over 512 is the 7th term of the geometric sequence. last example for our discussion on geometric sequence, let's consider this challenging problem. In an arithmetic sequence, the third, fifth, and 11th terms are distinct and form a geometric sequence. If the fourth term of the arithmetic sequence is 6, find the 2015th term of that sequence. First, we represent the terms of the arithmetic sequence. So we'll have a sub 3, a sub 4, a sub 5, 6, a sub 7, a sub 8, a sub 9, a sub 10, and then a sub 11. According to the problem, if we're going to consider a sub 3, a sub 5, and a sub 11, this will form a geometric sequence. But the original sequence that we have forms an arithmetic sequence. Also in the problem, we are given the value of the fourth term, which is equal to 6. Then therefore, in the original sequence that we have, we can rewrite this as 6 as our fourth term. Since this is an arithmetic sequence, then there is a common difference between the terms. And I will denote that common difference as lowercase letter d. Meaning, my fifth term would be 6 plus d. And then I can represent my third term to be 6 minus the common difference. Then continuing rewriting all of the terms in the given arithmetic sequence, we will have 6 plus 2d as our sixth term, 6 plus 3d as our seventh term, 6 plus 4d as our eighth term, 6 plus 5d for the ninth term, 6 plus 6d for the 10th term, and then lastly, for this 11th term, we will have 6 plus 7d. Now, from the given problem, take note that a sub 3, a sub 5, and a sub 11 forms a geometric sequence. So, here in our representation of the terms in the arithmetic sequence, I'm just going to consider 6 minus d, 6 plus d, and 6 plus 7d. Take note that these are the third, fifth, and 11th term respectively. Now, since this 3 forms a geometric sequence, then therefore, there's a common ratio that exists between the terms in this geometric sequence. So, I will now have the equation 6 plus d over 6 minus d is equal to the ratio between 6 plus 7d over 6 plus d. I will use this equation to solve for the value of d. So using now this equation that we have generated based on the given the problem, let's solve for the common difference or the value of d. So we cross multiply, then we will have 6 plus d multiplied to the quantity 6 plus d. This is equal to 6 minus d multiplied to the quantity 6 plus 7d. We can rewrite this as the square of a binomial 6 plus d. So if you're going to expand this one, this is just equal to 36 plus 12d plus d squared, which is equal to, if you're going to use the FOIL method, in simplifying this expression here, we will have 36 plus 36d minus 7d squared. Simplifying now this equation, we can cancel 36. And then what I'm going to do is to move all of the terms in the right side to the left side. Then I will have 8d squared minus 24d is equal to 0. Simplifying the equation by dividing both sides by 8, I will have d squared minus 3d equals 0. Solving for the value of d, in this quadratic equation, d squared minus 3d is equal to 0, we can factor this as d times quantity d minus 3 is equal to 0. Equating each factor to 0, we'll have d is equal to 0, and then we have d minus 3 is equal to 0. Solving for the value of d, we will have 3. Now, we have two values for the common difference. So from our previous solution, we already solved for the value of d, and those are 0 and 3. So now, how are we going to answer the problem? How are we going to find for the 2015 term of the sequence? But first, since we have two values for d, and we have represented the terms in the geometric sequence as 6 minus d, 6 plus d, and 6 plus 7d. If we try to replace the value of d in our terms here, if we consider d to be equal to 0, then we will have 6 minus 0, 6 plus 0, and 6 plus 7 times 0. And this will give us the sequence having the terms 6, 6, 6. Now, what about if we consider d to be equal to 3? Then we will have the sequence which has the term 6 minus 3, 6 plus 3, and 6 plus 7 times 3. 6 minus 3 will give us 3. 6 plus 3 will give us 9. 6 plus 7 times 3 will give us 21 plus 6, so that's 27. Now, since we have two values for d, and when we try to replace them on the terms of our sequence, it gave us two different sequences. But if you're going to take a look at the problem, it says here in the problem that the terms are distinct. What do you mean by distinct? The terms should not be the same. So we cannot have this sequence here. So we're not going to consider the sequence 666, since in the problem it says here that the terms should be distinct. Now, so meaning we're just going to consider the sequence 3, 9, 27, this sequence. And in this sequence, we're going to find for the 2015 term. If we're going to take a look at the sequence that we have here, the common ratio in this geometric sequence that we have is 3. Okay? So using this and the given a sub 1, which is 3, we can be able to find for the value of a sub 2015. A sub 2015 is equal to a sub 1 multiplied to the ratio raised to 2015 minus 1. Our first term is 3. Our common ratio is 3. We raise it to 2014. And this is equal to 3 raised to 2015. So meaning the 25th term of the geometric sequence is 3 raised to 2015. And then that's it. We already answered the problem.
Thank you for watching! Don't forget to click the notification bell and subscribe button para updated ka sa mga videos ko.